Today, shall we discuss any case study on protection switchgear?
Yes, ma'am.
Okay, shall we discuss? Yes, ma'am. Sir, anyone?
Real-time case study on transformer damage caused by a circuit breaker trip failure. The incident is based on an industrial production system failure conditions, and also a transformer fault occurred during normal operation in an electrical distribution system, and the productive relay detected the fault and generated a trip signal immediately. However, the circuit breakers failed to isolate the transformer from the current. This case study highlights the importance of reliable productions and maintenance.
Okay. So, can you give the introduction about this case?
Transformers are very important components in electrical power system and require proper protection during faults. Circuit breakers are used to disconnect faulty equipment from the electrical network safely. During abnormal condition, protective relays send trip commands to circuit breakers. If the breaker fails to operate, dangerous fault current continues flowing through the transformer. Excessive fault current produces overheating, insulation damage inside the transformer. Therefore, reliable breaker operation is safe for power system performance.
Can anyone explain the real-time incident background?
Real-time incident background: a major disturbance occurred in the power system because of overload and production issues. During the disturbance, one industrial transformer developed an internal winding fault. The overcurrent relay quickly detected the abnormal current condition in the transformer. A trip signal was sent to the vacuum circuit breaker for fault isolation. However, the breaker failed to open because of a mechanical problem in the tripping mechanism. As a result, transformer remained connected to the fault current for several seconds.
Okay. What is the system configuration?
So system configuration is the industrial power system used an 11 kV or 415 volt transformer with a rating of 2 MVA. The transformer supplied electrical power to motors, compressors, and industrial machinery. Overcurrent and earth fault relays were installed for transformer protection. A vacuum circuit breaker was connected on the incoming feeder side of the transformer. Protection was also available in the upstream distribution feeder. The complete protection system depended on fast and reliable breaker operation.
Okay, what is the causes of the circuit breaker failures? Can anyone explain why the circuit breaker gets fails?
The main causes of circuit breaker failure is the circuit breaker fail because the tripping mechanism become mechanically jammed. Dust accumulation and lack of proper lubrication affected the breaker momentum. The trip coil received the signal from the relay, but the breaker contacts did not open. Regular maintenance and breaker timing test got performed properly. Because of this failure, the transformer remained during the fault condition. This fault current started damaging the transformer winding and insulation.
What is the causes, fault current and its cause effects?
Fault current and heating effects. Fault current generates a very high amount of heat inside electrical equipments. Longer fault duration increases transformer temperature very rapidly. Excessive heating damages copper windings and weakens the transformer insulation. Transformer oil also decomposes because of high thermal stress. Gas formation inside the transformer tank increases internal pressure dangerously. In severe condition, this may result in transformer fire explosion.
Okay, can anyone explain about the sequence of the event?
The sequence of events: the internal transformer faults started at approximately 10:15 a.m. during normal operation. Within a few milliseconds, the protective relay detected the overcurrent conditions. The relay immediately sent a trip commands to the vacuum circuit breaker. However, the breaker failed to operate because of a mechanical locking issue. The fault current continued flowing through the transformer in the winding for several seconds. Finally, the production is isolated by the supply and stopped further damages.
Okay. What caused damages of transformer?
So damage of the transformer, continuous fault current caused severe overheating inside the transformer winding. The insulation between winding turns started melting because of excessive heat. Transformer oil became contaminated with carbon particles and combustible gases. Copper winding resistance increased due to abnormal temperature rise. Smoke was observed near the transformer conservator tank during inspection. The transformer required complete shutdown and extensive repair work after the incident.
What is the technical analysis?
Technical analysis: the productive relay operator correctly and detected the fault condition immediately. The main problem occurred because the breaker failed to respond to the trip signal. Backup production worked properly but operated after a time delay. The delayed fault isolation increased the thermal damage inside the transformer. The substation did not have dedicated breaker failure protection scheme installed. Proper maintenance and testing could have prevented this incident effectively.
So, what about safety and financial impact?
Financial and safety impact. The transformer failure caused a complete interruption of industrial power supply. Production activities stopped because electrical loads could not operate normally. The company experienced heavy financial loss due to downtime and repair expenses. Fire hazard conditions created an unsafe situation for workers near the transformer. Emergency shutdown procedures affect overall productivity of the industrial plant. The damaged transformer and breaker required expensive replacement and maintenance work.
Okay. What are the remedial actions can be taken?
The damaged transformer was isolated immediately from the electrical network after the incident. The faulty circuit breaker was removed and inspected by the maintenance team. Protection relay settings were updated for faster backup fault isolation. A breaker failure protection scheme was added to improve system safety. Thermal monitoring sensors were installed to continuous transformer condition monitoring. The company also introduced a strict preventive maintenance scheduled afterwards.
Okay, what are the primitive measures? What are the measures could have been taken?
Regular circuit breakers maintenance should be performed to avoid mechanical failures. Breaker timing test and contact resistance test must be conducted periodically, and a productive relay should be calibrated and tested at regular intervals, and a transformer oil testing help identify insulation deterioration at an early stage. Industries can use AI predictive maintenance for fault prediction, and proper operator transformer maintenance planning improve overall.
Okay. Finally, what lesson we have learned here?
This incident clearly showed the importance of reliable circuit breaker operations. Small mechanical problems can cause severe transformer and system damages. Fast fault isolation is necessary to reduce thermal stress during faults. Backup protection system should operate quickly when primary protection fails. Smart monitoring technologies improve fault detection and planning, and the and preventive maintenance is more economical than emergency repair and replacement.
Okay. Finally, who's going to conclude?
The conclusion: this case study explained how circuit breaker trip failure damaged an industrial transformer. The failure allocated fault current to flow continuously through the transformer winding. Excessive heating caused insulation damage, coil contaminations, and system shutdown. Reliable protection systems are essential for safe electrical power operation. Modern substations should be intelligent monitoring and breakers failure protection schemes. The proper maintenance and predictive analysis can prevent similar incidents in the futures. Thank
Okay.
you.
Okay. Finally, we are concluded with the regular maintenance is very very important to avoid the damages in features with the help of latest technology. Okay. So I hope you know you understood what is case study on transformer. So we'll meet in next class.